Welcome to Green Academy. Today we're going to look at the forces acting on a particle in a magnetic field, especially the magnetic force. Now, the first question asks, if a particle experiences a force in a magnetic field, what are the conditions or two things you can deduce about the particle? Now, for a particle to experience a force in a magnetic field, first it must be a charged particle. And second is that the particle must be in motion. That means it must be moving inside the magnetic field. A stationary charged particle does not experience a force. So the second condition is that the particle must be moving, or it must have a velocity. So when these two conditions are met, then it will experience a force. Now, the next one is we have a fast beam of electrons entering a strong magnetic field, and the magnetic field is acting out of the page as shown. Now, as you can see, the blue dotted lines indicate magnetic field which is coming out of the plane of the page. And we have a beam of electrons entering from this side, and of course the magnetic field is acting out of the page as shown by the dotted lines. Now, how do we deduce what is the direction of the force? Now, we use the Fleming's left hand rule. Now, how do we use the left hand rule? The left hand rule is such that the thumb points in the direction of the magnetic force. The first finger gives you the direction of the field, and the second finger is used to give you the direction of the current. And what we have here is a beam of electrons, which is negative charges, and by convention, current is the flow of the direction of current is the flow of positive charges. So therefore, what we have is the direction of current is taken to be this way, even though the beam of electrons are moving towards the left, right? And we have the field acting out of the plane of the page. So what you're going to do is you're going to have your first finger pointing up, that means coming out of the page, and your second finger pointing towards the right. And when you set this up, okay, the first finger pointing up and the second finger pointing to the right in the direction of the current, your thumb will point downwards, in the sense that it will point downwards towards in the plane of the page. So that gives you the direction of the force. That means the force will be acting down. So direction of the force is acting down, and therefore, and when the beam of electrons enter, it is going to start experiencing a force this way and is going to turn. Now, the interesting thing about this is that as the direction of the beam changes, its direction of the current also changes in that sense. And technically, once it has moved this way, you can say that the direction of the current at this instant is this way. And if you apply the Fleming's left hand rule again, you'll find that the direction of the force will follow it in this way. And you will end up having the beam of electron actually moving in something like a circular path, right? It will actually make a circular path. And this will be the motion or the paths taken by the beam of electrons inside the magnetic field. I hope this makes it clear. Thank you very much.